This spreadsheet shows you the simple functions that Excel has built into it to deal with the normal distribution, which is much more flexible than using old-fashioned tables. There's two main questions you can ask. You can ask about the normal distribution. One is this way round. If you know how many standard deviations above the mean you are, like we were 1.63, so you type that in by hand, 1.63, this is the answer that will come out using a formula. So give it this, how many standard deviations above the mean, it'll give you this. And that's the formula you put into there, norms dist. So norms dist takes the number of standard deviations and turns it into a proportion that's going to be below that level. And we saw that 1.63 is almost 95. If you go for 1.64, actually that's slightly better. That's about as close as you can get to 0.95 without having more decimal places on. So 1.64 standard deviations above the mean is always going to be about 95% less. And you can change it. We also did 2 standard deviations above the mean, we saw it as 97%. That's the same for any normal distribution. 1 standard deviation above the mean, it's going to be 84% less than that. 0 standard deviations above the mean, you should know what this is going to be straight away. 0 standard deviations above the mean means you're actually on the mean, so it should be half above and half below. That's 0.5. If it goes negative, then it means you're below the mean. So negative 1.64, because symmetrical, you should be able to predict what that's going to be. Negative 1.64 above the mean, or 1.64 standard deviations below the mean, means that only 5% is below this level. It's the same distance below the mean as the 95% level was above the mean. So that's what you can do with that way around. You can put in a number of standard deviations above the mean, which is this. So the z-score is the number of standard deviations away from the mean you are. So put in a z-score and it gives you a proportion that's below that. The other thing you can do is say, well, okay, what proportion do we want to have below the level? So it's the other way around. So if we want 95% below it, what level has it got to be at? So it'll give you the z-score. You put in the proportion that gives you the z-score, and the formula for that, you type in the number this time, the formula for that is norms in, where inverse means goes the other way around. And it's saying here probability, which is really the same as putting in proportion. So if you wanted to know, okay, what level do you have to set it at to have 80% below it? That's 0.84 standard deviations above the mean. So for example, if I was setting an exam and I wanted to try and make sure that 90% of people did not get an A and only 10% did, I'd set that as 0.9, and I'd know that I want my grade mark for the A, the top grade, to be 1.2 standard deviations above the mean. If I want to make sure that only 10% of people fail it, then I'd get 0.1. So that, in that case, the pass mark for the exam would have to be 1.2 standard deviations below the mean. So I need to know the mean and standard deviation. I can then calculate what my pass mark should be. And those are some of the things. Well, those are the two main questions you can answer using normal distributions. And as we'll see through many examples, you can do an awful lot with that.